So I'm going to be talking about contracts for protocols. And so I think a lot of us here are familiar with Racket's contract system. I know for sure some of you are very familiar with Racket's contract system. But just as a sort of refresher, we can take everyone's favorite function, which is, of course, standard fish. And suppose we use standard fish correctly. We've read its documentation. We know all of its keyword arguments. And it has a few interesting ones, like color and direction. And you get your nice standard fish, which is good. But what happens if you, I don't know, forget what a direction is or didn't quite read the documentation correctly? And you provide a symbol that is not actually a correct direction? What do you get? Well, you get this really nice descriptive error message, more or less for free. So you write down a declarative description of what the inputs and outputs of your function should be. And if a user supplies something that's incorrect, you get all of this information. What was expected, what was given, and more importantly, or very importantly, what module is to blame for this particular violation. So in this case, since it's a library function that we're calling, and we gave it a direction that's not a direction, it's the client's fault. And you can see it's blaming this point, an anonymous module, which is the Racket. Okay, but that's not the only kind of blame we have. What if I have a fake standard fish function, which returns the string, I'm a standard fish, and I give it the same contract, or more or less the same contract as the regular standard fish. And if I use it correctly, so the client has satisfied its obligation, then I get a different kind of contract error that says, oh, your function broke its own contract. Okay, so that's what we call server-side blame, because it promised a picture and gave a string. And you get these nice error messages for free. That's one of the great features here. Okay, so people generally know that. But I want to play a little bit of a game to sort of hammer that point home. And actually, this may remind you of something we saw yesterday when we saw exemplar. This is always a sort of game that you can play with your contracts to see if they're good enough. And there's two sort of properties that we would like, given a sort of English level description of a function, as well as a contract that you've written. Is it a good enough contract? And there's two sort of properties that you may think about. One is that it will always blame a bad implementation. So if I give you something that doesn't satisfy what you think the specification should be, you should get a blame at some point, pointing to the server. And that also it's not too strict, so it's never going to actually blame a good implementation of the function. Okay, so we can play this game a little bit here with a very simple function, which is sorting. So if I have a sort function, typically I would give it some comparator as a first argument, which is a procedure, and then an input list, which is unsorted, and then I would get back out a sorted list. Okay. So here is a first draft of a contract. What do you think? Is this a good contract? Bad contract?
Bad contract.
Bad contract. Why?
Because you don't want a procedure. You want a procedure that takes probably two arguments and returns, yeah.
Exactly. The procedure, you have no idea how many arguments it takes, what the inputs and outputs are at all. So in particular, this will violate one of the properties in that I can give you a bad comparator. In this case, this one doesn't take in any arguments. And the server code is going to explode and say, oh, I'm giving you two arguments, but you don't expect any. Okay, so that's bad. So that's not a very good contract. We can make it better. So in Racket, we have function contracts, where we have two arguments here. In this case, it could be anything, and then the return boolean. Okay. All right. How is this? Is this doing better for sorting? I think so. But is it really good? Yeah.
There's no guarantee that those NECs and the type in the list are the same.
That's true. That is not something that we're going to solve here. As type language, maybe you'd be able to solve that more easily. But we'll keep them NEC for now. Yeah.
Are you allowed to comment on the lists? Or?
Say it again?
There's a connection between the lists.
Yes, there's a connection between the lists. What kind of connection?
They should have the same elements.
Yeah. So here is one function that would not satisfy or that would satisfy this contract, and it's not a very good one.
Something happened to the mic.
Oh,
The battery may be low.
I was able to turn it on once more, so.
If it goes off again, the battery's low.
Yeah.
Don't worry about it.
Okay, so here is a very bad sorting function that would satisfy that contract. It works, okay? The identity. So that's sort of bad. So how would you fix that? This is a sort of a little bit more of a sophisticated contract where we're actually saying something about the input and output lists, that they're not just lists, that the relationship is actually the thing that you get out at the end is sorted with respect to the comparison function that I gave you, okay? So that's better. That's even better. Is that the best that we can do?
You could guarantee that all of the elements in the input list or in the output list.
Exactly. So in
and nothing
particular,
else.
yes. So in particular, this bad implementation also satisfies this seemingly very good specification. And so you fix that by saying, okay, a permutation. The input has to be the permutation of the output as well as being sorted. Okay? So this is a very good, basically full specification of it, right? Okay. So that's the sort of landscape that we have right now. And I want to talk maybe a little bit about what that looks like.
At this point, it feels like you might have just written your function out twice.
Say it again?
No.
This contract looks almost like you wrote your function twice.
What do you mean by that?
Like, your function is not going to be bigger than that contract.
But that's not the same as writing the function twice.
Right. So I mean, this is the specification for sort. You can imagine there are many sorting procedures that would satisfy, quick sort, merge sort, whatever. So there's a lot of still choices that you can make that are not specified by this contract.
No, not the particular. Oh, I see. Okay.
There's a distinction in the size of it and whether it repeats it, right? That's a major important distinction.
Yep.
Okay, so this is sort of what we're looking at, I guess, in terms of normal kinds of contracts and what we just saw. You have the bottom, which is first order properties, we would call flat contracts. And then you have some higher order ones, getting a little bit more sophisticated, arrows and maybe vectors, because they're beautiful. And then if you want to get even more crazy, you can do dependent contracts, which we saw a little bit of, with arrow I and struct DC and something like that.
Just check if that's gone off again.
Oh, yeah, so I
Okay,
fixed that.
this time, put it error battery. Sorry.
The same way.
Yeah.
Is it food?
Okay.
Okay, good. All right, so this is a sort of ordinary landscape. What I want to talk a little bit about is what I think about most often, which is what happens up here, way out in outer space, okay? So some sort of more unusual contracts. So these are the things that you might use on the everyday, but occasionally you might want something a little more interesting. Okay, so let me take a look at some documentation, some scribble from the standard library. Here we have the description of start doc, which is part of Racket/draw, and you can notice that at the bottom there's this caveat which says, for relevant devices, an exceptions raised if start doc has already been called, et cetera, et cetera. So there's several other functions that this is intertwined with. So in particular, you have to call start doc, and then you have to call start page, end page, start page, end page, when you want to create new pages of a document, and then you have to call end doc, and that's the specific sequence that you have to use this, and otherwise you're going to get an error. And it turns out that internally this is not implemented using a contract. These are sort of ad hoc checks that implement this. Another one, which is a little bit scarier, is this set stipple method. And at the bottom, you see they have a caveat that says, if the bitmap associated with the brush is modified in a particular way, then the effect is unspecified, okay? It's a little scary. I thought we were in a scheme-like language and things are generally specified. Let's see, okay? And here's another one that's sort of, and you might have actually run into this one when you're working with a hash table. Caveat in bold concerning mutable keys. If you have a key that's mutable and you mutate it while it's a key of a hash table, then you get unpredictable behavior because the hash code might have changed, okay? So these are sort of peppered throughout libraries in general, and maybe we want to do something about this. Okay? So I'm going to give a very, very simple example to illustrate how this might work with another function called current memory use. Current memory use just gets the amount of memory that Racket has been using. If you pass it the cumulative symbol, it returns the number of bytes allocated since startup, so across all of time. So in particular, this last, if you provide this cumulative argument, there's an implication that the return value is always going to be increasing over time. Because it's not including things that have been reclaimed by garbage collection. So you're always increasing the number of bytes. Okay? Okay, and so if I call this, I'm going to get back a number that's always increasing. And so this is sort of what the picture in my head of this looks like. I have a client and a server, and they're going to be playing a little game where they pass values back and forth. So the client will throw a value over to the server, this cumulative symbol, and the server will throw back another value to the client. And you do this a couple times for that interaction. Okay? So if you sort of draw that out in a picture, you get a sort of transcript you can imagine. On one side, this is the values that the client is sending over. And on the other side, this is the values that the server is sending over. And so there's one key idea here, which is sort of how we're going to solve this problem. And the idea is that what we're going to do is we're going to reify the sequence of values in this transcript. So what I'm going to do is I'm going to make a data structure out of this transcript. So if I care about the return value of current memory use, what I'm going to do is when it returns a value, I'm going to plop it into a list or a stream-like data structure. And then every time current memory use returns, I'm going to add it to the end of this data structure. Okay? And this is sort of a very much a classic functional programming trick where we take something that's sort of abstract and nebulous, like the communication between two components, and we make it into something concrete, something first class of value. And then when we have a first class value, then we can do something with it. In particular, in the contract world, we're always talking about our specifications as code, as predicates. So once I actually have a list, I can just write a predicate that says the list is increasing. And then I can get a Boolean out of that and then use that to have a contract violation. Okay? So this is the actual mechanism to enforce this contract. It's called a trace contract. And you'll notice that, okay, if you ignore these two lines, the contract looks more or less like what you would write for current memory use. It takes in a symbol, and then it will return a natural number. So if you just think of this as a let, it returns a natural number. But the slight twist here is that I'm also specifying that the sequence of return values that I get back from current memory use is going to be increasing. So you take all of those return values, you have a data structure, and now they're always increasing. Okay. So the sort of anatomy of this form is that you declare a bunch of things called trace variables, and you associate with each one of these variables with a contract. So in this case, natural. You have a sort of body contract, which is a sort of ordinary shape, the ordinary contract that you would write without trace contracts. And then you have predicate clauses, that specify what should be true of those trace data structures. And the full here means that you're going to get the full history, everything, in a list or stream.
You always get the full history?
When you say full, you always get the full history.
But we don't need it in this case.
Right. We'll get to that. Yeah.
How do the other two parts work? In particular, I'm surprised that it's not increasing of y. So,
So when you specify this predicate clause, you specify which trace variables that you depend on, and then it will provide them in order to this function. So if I had, let's say, x, y, and z, then it would expect increasing to be a 3-argument function, and then it would pass them along.
Just bind the y to the list and then return a boolean.
Yeah.
Do you get something out of not doing that?
We'll see. Yeah. Okay, so here is an example of using this contract on current memory use. And so I call it and I return 3 and 8, but it turns out that this is actually a buggy implementation of current memory use. And actually, it doesn't increase over time. I get a blip here. I get 2 after I've gotten 8.
those numbers are way too small.
Oh yeah, this is a fake version that I cooked up. But what you get is an error message very much similar to what we saw before. So it says current memory use itself is broken. So this is a server-side blame. It produced 2, but that's wrong. And what it does, since you have the full history of what happened, you see the actual trace data structure. You see it's a list with 3, 8, and 2. And you get the appropriate blame, because this is a return value from the function, so that means that it's server-side blame. Okay, so getting back to Robbie's question about, do you really need the full history of everything that happened? The answer in the previous case is obviously no. It's very, very wasteful to consider the entire history of every current memory use invocation that you've gotten. So what about performance? What do we do in that case? So the full predicate clause that I showed you, you wouldn't really use that in practice generally, because usually you have some insight that would lead to better performance. And in this case, the trace data structure that you really want is not a full list, a full stream, but really just a single number, which is the last return value that you got. So this is the syntax typically of how you would actually write one of these things. The first 2 parts are the same, so the trace variable and the inner contract are the same, but we have this accumulate clause instead of the full one. And what this is saying is that you can choose to have an accumulator. In this case, it's just an integer. And then what I'm going to do is when I get new values, I'm going to fold that into the accumulator. So in this case, I have 0 initially, which is the starting accumulator. As I get return values from current memory use, I check to see, oh, is this larger than the last accumulator? If so, then what I just got now is the new accumulator. Otherwise, I have a special false value that's going to indicate that a contract violation should occur. All right? Does that all make sense? So this is how you get around the performance issue. And the interesting thing is this was actually a real bug. I didn't make this up. So Alex, who maintains the plot library, had an issue with current memory use quite a while ago. He was plotting what it was doing over time, and noticed that on occasion there was these blips that it goes way down when he used the accumulate symbol. So why is that? Well, of course, Matthew fixed it in about 10 minutes. But the interesting thing for me is not necessarily this first question, which is maybe relevant for Matthew. What caused the bug and how can we fix it? But for me, the interesting question is more so, how could we have prevented the bug in the first place? So if we have these high-level descriptions of what these functions are supposed to be doing, and we actually encode that in the contract system, then we would be able to detect some of these things, maybe ahead of time in the test suite, or perhaps in real-life applications, some of these contract errors would actually occur, and then they would be reported before you had someone, trying to plot some of these functions. Okay, so that's just sort of general philosophy about using contracts. Okay, so that's the trace contracts, but I told you a little bit of a lie at the beginning. I said that, we have a sorted function and we have this full specification of sorted. That's actually not quite true. Does anyone know what's going on with this invocation of my sort? Any guess? No?
The sort function is wrong. It doesn't follow. I'm not sure exactly what.
Transitive.
Yeah, transitive or what. I don't know what kind of ordering is specified. That one certainly
That's
is.
why I left.
False. I'm just giving back the constant false in my comparator. Okay. Obviously, that's not a valid total order. Okay. But the contract that we specified earlier for my sort didn't say anything about the fact that your comparator had to be a total order, right? You said it's a procedure, 2 arguments, and then returns a Boolean. Okay. So, can we do something about this? Could we have a contract that actually enforces that is a total order? No.
I mean, it's okay to have elements that are considered equal to each other
Mm-hmm.
that are not less than. I mean,
Sorry, less than or equal, right? So if it's always false, you wouldn't have a totality.
It needs to be a reflexive.
You can sort with a partial order, though.
yeah,
Right.
So maybe we should relax sorted by.
Right. So I'm assuming in this implementation, I want a total order for the comparator. Yeah. Okay. Oh yeah. Go
I was
ahead.
going to ask. I'm not familiar with the term sorted order by that, total order by that.
Sorry. So in a total order, so in a comparator, we usually assume certain properties. Okay. And actually, I'll say what the properties are. These are the properties that we assume, usually comparators that would hold to them. So if we have 2 elements, you can either compare one way or the other way. One of those 2 you're going to get true. It's reflexive, it's anti-symmetric. So if you have both ways, then they're equal. And then it's transitive. So if you have A less than B, B less than C, that implies A is less than C. So these are properties we usually would expect for comparators.
Okay. Total order just means that it doesn't always return the same value, same true or false, regardless.
Right. Yeah. Unless it's a very trivial total order, yeah, that would be true. You wouldn't always just return.
You have the total order on the single element set.
Yeah, that's the trivial one. Okay. So if you think about the sort of classic contract system, you can do 1, 2, and 3 typically. So if you wanted to check if it's total, you would say, okay, I'm going to check less than or equal X and Y, and then I'm going to check it the other way and make sure one of them is true. Okay, maybe both of them could be true if it's an anti-symmetric case, but at least one of them is true. And reflexive, you can also similarly check. Anti-symmetry, you can check as well. But the last one's a little bit. Oh yeah, Robbie.
just before we move on to the interesting part about transitivity.
Sure.
With our Racket sort functions,
Yeah.
You generally want to supply a strict order,
Mm-hmm.
and it leaves the elements in the order that they were in when they're not comparable to each other.
Okay.
Yeah.
Yes.
So like you string strictly less than.
Yes. Sure.
It's like this is. I'm looking forward to seeing how we're going to deal with transitivity.
Yeah.
It's a very interesting contract thing. But just if you actually want to sort a list.
Yeah. So I'm not going to claim that this is a good contract for Racket sort function.
Right.
I'm sorry. I'll make that very clear. This is a pedagogic example. Okay. Sorry. Right. So the first 3 properties we can deal with. But transitivity is much harder. And the reason it's much harder is because we are actually talking about not necessarily one call to the comparator, but 2 calls to the comparator. So in particular, you have A and B, that would be one call. And then B and C, that may be another call. And then you're talking about a property that relates those 2 calls together. Okay, so as a quick example, if I less than or equal to 1, 2, less than or equal to 2, 3 by transitivity, that should imply that 1 is less than or equal to 3. But if it's false, that's bad, and I should know that, and that should be a contract error if I enforce that this is a total order. So how do we do this? Well, we can't typically do this with the ordinary contract system. But we need something a little bit special. And we can use trace contracts in order to do this. So here is basically all the code that you would need to do this. And what you do is, I'm going to take a look at all the inputs and outputs, and I'm going to accumulate a directed graph of these things. And what I'll do is, every time I know that something is less than something else, less than or equal to something else, I'm going to create an edge in this directed graph. And if there's ever a point where there's a cycle in the graph, that means that there's some violation of transitivity, in which case, then I should get a contract error. So that's one way of enforcing this property. Now, would you actually want to do that in practice? That's a question that would have to be left to the programmer who's writing the contract. I mean, in general, you can have very, very expensive contracts, and depending on what situation you're in, those may be acceptable, those may not be acceptable. Maybe they're only acceptable when you're running the unit tests, etc.
I'm not super familiar with Racket contracts, so I'm going to ask, similar to one of the typing presentation from yesterday, is it possible to just turn contracts off for a specific run of code?
So in general, it's not possible to just disable contracts altogether, but you can write contracts that will let you sort of flag it and say there's sort of different levels to this contract. So in particular, there's something called option contracts, which will let you say, you know, for the most part, I want to disable this, but at a certain point, I want to turn the checking on. That's a more unusual part of the contract system, but it's present.
Don't turn your contracts off.
In general, it's a bad idea.
This is the sort of thing, this is a guarantee, actually the transitivity is a guarantee about user code, but like with the monotonic guarantee from before they increase it, that's a guarantee about your code. Once you've sort of guaranteed that that's true, it's sort of, the contract sort of becomes documentation rather than something which needs to be actually checked.
Running your code without your contracts is like taking a sail without your life jacket.
That's one opinion, yes. Indeed. But yeah, I mean, I think the more general answer is you usually want them in, but maybe if you have something that's particularly expensive, and it's not maybe catastrophic if you don't check it, then perhaps you want a different level of checking. That's something that the programmer should decide. Okay, now the nice thing about this, and one of the properties of the system, is that it sort of composes with all of the other contract combinators. So in particular, if I wanted to have a total order contract, then I just AND-C together all of those constituent properties. In particular, the transitive one is just the one at the bottom. And it looks sort of ordinary, and it works as you would expect. So really, there's actually some state management that's happening behind the scenes that this is sort of dealing with for you. So if you had different functions that you attach the transitive contract to, they're not going to sort of get their mutable states mixed up. And you as a programmer don't really have to worry about that. That's one of the properties that I want to have. And then so here is how you would adjust the MySort to deal with it. Okay, so here's some of the criteria we wanted from the system. We wanted to express these history-dependent properties, where you have things that happen over time. And one of the interesting things, which I think the total order example shows, is that it's not just about mutation. So I think maybe there's a misconception that says, oh, if I have just pure program, I don't ever have these sorts of temporal properties that I care about. That's obviously not true. We just saw an example of a total order. You know, that could be a pure program, and you might care about that property. Or monotonicity, as we heard. It is another property that you might care about in a pure program. Okay, you can efficiently monitor, so that full option that we saw at the beginning is not the only thing that you can have. You can customize what data structure that you want to use. It isn't limited to only certain kinds of properties, so you can write arbitrary predicates, and they work, and they're natural, and just like the rest of the contract system. Hopefully it's easy to use. I don't really know yet. I think it's relatively easy to use. As we saw, it composes with existing contracts. And another one that we're hoping to figure out is this actually helpful for bug finding? I mean, that's one of the things that the contract system is really amazing at, pinpointing specifically where bugs are. Does the system actually satisfy that? We're not quite sure yet, but we'll hopefully figure that out soon. Okay, so the last thing, maybe most important thing, is you can use this. So it's not on the Racket package server yet, but I have a GitHub repo where you can install it for yourself and try it out, and there's some documentation. So let me know if you find it useful and find some properties in the wild that you would like to use these contracts on.
All right, thanks, Cameron.